Hello, so this is video number 5, and this is solving exponential equations. I thought we were going to inequalities first, but no, it's actually, we're gonna be solving exponential equations. So please feel free to give me any feedback in the comment section. Any feedback is welcome on how I can make these videos better. If you spot any mistakes when I try to solve them very quickly, please feel free to point it out. And yeah, so this is going to be how to solve exponential equations, and you're going to be using your calculator a lot here. So I'm just going to I'm not going to do all of them, I'm going to do some of them so that you can sort of see how you can solve them. So let's start with the first one, 1a. So 5x is equal to 18. Well, we don't know how to solve this. Well, actually, we have looked into how we solve this. And basically, we can say that, hey, your calculator has two log bases, log base 10 and log base e. And we will be discussing log base e at a later point. But for now, let's just say that, hey, if I take log base 10 of both sides, then I can bring this power to the front, x, and I see that the value of x is going to be log base 10 of 18 divided by log base 10 of 5, right? So once I get this, then I can simply solve for x. So your log base 10 of 18, so you just want to put log 18 divided by log 5 in your calculator. And that is 1.795. So 1.7, I would say 1.80 to 3 significant figures. But please, I don't really remember, but I think it should be 1.80 to 3 significant figures, or it could be 1.79. But let's keep it as 1.80 if it's 1.79. So the answer was 1.795. So you can ask your teacher on how to give it to the correct number of significant figures. This should be from how I understand it, but again, always good to double check. And you can, again, recheck. If you put 5 to the power 1.80, then you get you get 18.119. It's very close. Well, your actual answer was 1.795. And when you put that, you get closer and closer to 18. So you always okay to substitute back and check your answer. So question B is exactly the same. You can follow the same procedure. So question part C, 3 to the power 2x is equal to 8. We're going to do the same thing. So you're going to get 2x, log base 10 3 is log base 10 8. 2x is equal to log base 10 8 over log base 10 3. And you have the extra step of dividing by 2 to get your answer. So I'm just going to leave this as it is. And I think you can sort of get the idea on how to solve these. We've looked at 1, 2, A, B, and C. So let's look at D. 2 to the power x plus 1 is 25. If I take log base 10 of both sides, then I get something like this. So x plus 1 log base 10 of 2 is going to be log base 10 of 25. So x plus 1 is equal to log base 10 of 25 divided by log base 10 of 2. And to get x, you just subtract 1 from both sides. But again, this is solvable. This is something we've seen before, so I'm not going to go further here. And this is the same thing. E is going to be exactly the same, except after you get log 20 over log 3, you want to plus 5 and divide by 2. There's just some extra steps here for E. So I'm going to leave you to do these questions because it's good practice. So let's try this one. 3x is equal to 2x plus 1. Well, that's going to give me x log base 10 3. I'm doing these very quickly now. X plus 1 log base 10 2. So now I have x log base 10 3 equal to, if I distribute it within the bracket, I get x log base 10 2 plus log base 10 2. And if I bring this here, I get x log base 10 3 minus x log base 10 2 is equal to log base 10 2. And I get x log base 10 3 minus log base 10 2 equal to log base 10 2. And finally, I know that x is log base 10 2 divided by log base 10 3 minus log base 10 2. And if you calculate this to three significant figures, you just want to go to your calculator, you do log 2 divided by log 3 minus log 2. That is 1.71 to three significant figures. And you can test it. You can put it back in your equation. The 3 to the power 1.71 is 6.544. And 2 to the power 2.71 is also 6.54. So it's very close. So again, part G is going to be, part G and H, they're going to be very, very similar. They're just some extra algebra, and you just want to make x your variable. You want to make x your variable, and how you can make your x variable is that you want to take all terms containing x to one side, and you want to factor your x out. So let me do G as well, so that you get more used to it, and I'll leave H for you to try. So 5x plus 3 is equal to 7, 4 minus 3x. So x plus 3, I'm doing this a bit quickly here, log base 10, 5. But basically what I'm doing is I'm taking log base 10, 5x plus 3 on both sides. Log base 10, 7, 4 minus 3x. And we know that we can bring the powers in front. So x plus 3 log base 10, 5 equal to 4 minus 3x log base 10, 7. And now I want to distribute this because I want to isolate x. I'm looking for x. So x log base 10, 5 plus 3 log base 10, 5 is equal to 4 log base 10, 7 minus 3x log base 10, 7. And now putting the x terms on the same side, I get log x log base 10, 5 plus 3x log base 10, 7 equal to 4 log base 10, 7 minus 3 log base 10, 5. So if I factor out x, I get x log base 5 plus 3 log base 10, 7 equal to x 4 log base 10, 7 minus 3 log base 10, 5. So now I can finally solve for x. X is going to be 4 log base 10, 7 minus 3 log base 10, 5 divided by log base 10, 5 plus 3 log base 10, 7. So this is your final answer. And you can just put it in your calculator. You have 4 log 7 minus 3 log 5 divided by, and again, in your calculator, it's automatically understood that if you just have log, then the base is 10. Divided by log 5 plus 3 log 7. And that gives me 0.397 to three significant figures. And you can take this back and you can check. 5 to the power, your answer plus 3 is 236.74922282. And 7 to the power 4 minus 3 times your answer, that is also the same thing, 292. So if you substitute this, or you substitute the longer form back into your equation, both sides give you 236.74922282. So that is always a good way to check your answer. You just substitute back and use your calculator to confirm that you have the correct answer. So I'm going to leave H to you. So I'm going to do J, and I is essentially the same thing. I have 4x is equal to 7, 3x. Well, now I can always take the log. I can say that, hey, I can take log base 10 for x equal. And the reason I'm taking base 10 is because it's easy to use your calculator. Other bases aside from 10 and e, and we haven't learned log base e yet. We'll do that at a different section. But basically I'm using base 10 because it's easy to use on your calculator here. So log base 10 for x is going to be equal to log base 10 7 times 3 to the power x, right? And I know that my left-hand side is just log base 10, comes to the front, log base 10 4 is equal to log base 10 7 plus x log base 10 3. Basically, I'm using the multiplication rule to separate it out like this, and then I can bring the x to the front. Now I want to put my x on the same side, on the left-hand side. So I say x log base 10 4 minus x log base 10 3 is going to be log base 10 7. So if I factor x out, I get log base 10 4 minus log base 10 3. That is going to be log base 10 7. And finally, x is going to be equal to log base 10 7 divided by log base 10 4 minus log base 10 3. And that is your final answer. So you just put it in your calculator and see what the answer is, but I'm going to leave you to do that. And let's do one last question. Let's do question part, the last one, L. And it's the same thing. Basically, you take the log both sides and you separate out and you find your variables. So log base 10 5 times 2x minus 3 is going to be log base 10. I'm so sorry. 4 times 3x plus 4. Right? And I can separate this. I can write it as log base 10 5 plus log base 10 2x minus 3. And this is going to be log base 10 4 plus log base 10 3x to the power 4. I'm separating it out using the rules that we have learned before. Now, I want my terms with x on the same side. So log base 10 2x minus 3 minus log base 10 3x plus 4 is going to be equal to log base 10 4 minus log base 10 5. And now I can write this as x minus 3 log base 10 2 minus x plus 4 log base 10 3 equal to log base 10 4 minus log base 10 5. So when I simplify it out, I get log x log base 10 2 minus 3 log base 10 2 minus x log base 10 3 minus 4 log base 10 3. And I have log base 10 4 minus log base 10 5. So now I want to write all my terms containing x on, keep my terms containing x, and then I want to write these terms, the constant terms. These are my constant numbers on the other side. So that's going to be log base 10 4 minus log base 10 5 plus 3 log base 10 2 plus 4 log base 10 3. And finally, you can factor x out. And when you factor x out and you divide both sides, your final answer is going to look something like this. 5 plus 3 log base 10 2 plus 4 log base 10 3 divided by log base 10 2 minus log base 10 3. So I think this is going to be your final answer. And you can put it in your calculator to simplify it to 3 significant figures. So log 4 minus log 5 plus 3 log 2 plus 4 log 3. That is your numerator, and you want to divide by log 2 minus log 3. And that gives you minus 15.4. 15.4. That is your x to 3 significant figures. And you can substitute it back always. So 5 times 2 to the power, your answer minus 3 is some value, and 4 times 3 to the power, your answer plus 4 it should give you the same value, and you can always put it back. And when you substitute back, you can see that both sides simplify to 1.429 times 10 to the power minus 5. So you always want to substitute back to check. And that is how you do solve exponential equations for part 1. So show that. So 2a says that show that this can be written as this. So let me just take this, right? It says 2x plus 1 plus 6 into 2x plus 1 is equal to 12. Well, I know using the rules of exponents that I can write this as 2 times 2 to the power x, because I can, when I'm multiplying and I have the same basis, the exponents are going to add. So I'm going to add x and 1. So these are going to be added, and I get exactly this. So I write the first part as 2 to the power x, and I do the same with the second part, 2 to the power x. And the dot is just to represent multiplication. So finally, I get 2 times 2 to the power x plus 12 times 2 to the power x is equal to 12. And that is, I think, oh, because this was minus 1. Minus 1, so I could write 2 to the power x divided by 2, right? Because this is going to be x minus 1 when you use the rules of exponents. So 6 by 2, this is going to be 3. So 2 times 2 to the power x plus 3 times 2 to the power x is equal to 12. So we have shown that. So solve this equation giving your answers to 3 significant figure. Well, what does this tell me? If I consider 2 to the power x as an apple, I have 2 apples, I have 3 apples, so I can add them together. It's going to be 5 times 2 to the power x, right? 2 of something plus 3 of that thing is going to be 5 of that thing. It's going to be 12. 2 to the power x is 12 over 5, and x is going to be log, and I'm doing this quickly here because we have done this many times now, divided by log base 10, 2. And to 3 significant figures, you just want to put it in your calculator. Log 12 by 5 divided by log 2. That gives you 1.26. And you can substitute back. You can always substitute back. 2 times 2 to the power of your answer. 2 times 2 to the power of your answer plus 3 times 2 to the power of your answer. Sorry, so if you put in your calculator 2 times 2 to the power of the answer that you just got plus 3 times 2 to the power of the answer that you just got, that should give you 12. And it does when you substitute it back. So it has to be 1.2630 something something. But okay, so that is how you do question 2. And I believe question 3 is essentially the same thing that you did in question 2. So this, if I just show you how to do A very quickly, you get 2 squared times 2x. And when you simplify this, you're going to get 2 to the power x plus 2, which is exactly what we have here. Plus 2 to the power x is going to be 2 squared. 2 squared is 4 times 2 to the power x plus 2 to the power x is equal to 2 squared is, again, 4. Where 4 of something plus 1 of something, that's 5 of something, right? And then finally, 2 to the power x is 4 over 5. X is, we have been doing this for so long now, log 4 over 5 over log 10, 2. So again, to get from this to this, I think you are familiar, but you want to take log base 10 of both sides, and then this x is going to plop out in front, and then you divide. But you get the idea. And I think now you're very capable of solving these equations. And I think most of these questions here you are able to solve them using the same ideas that we have covered in 1 and 2. So let me just do one more here. Or 2 more. Let's do 2 more. Okay, sorry. So let's do 2 more. Let's do f. Well, f tells me that I have 3 times 3 to the power x, because that's going to simplify to 3 to the power x plus 1, minus 2 times 3 to the power x over 3 squared, right? Because this simplifies to 3 to the power x divided by 3 squared. And this is going to be 5. So I have 3 times 3 to the power x minus 2 times 3 to the power x divided by 9 is equal to 5. So if I multiply both sides by 9, then this is going to cancel out in the denominator, but I also have to multiply the first term. So 3, 9 3s are 27 times 3 to the power x minus 2 times 3 to the power x is 5 9s are 45. 27 minus 2 is 25 times 3 to the power x is 45. And 3 to the power x is equal to 45 by 25. That's 9 by 5, I think. And finally, you can solve for x as log 9 by 5 divided by log 3. Log base 10 of 3. And you can check. You can always put it in your calculator. 9 by 5 divided by log 3. It gives you 0 point. So if you, to 3 significant figures, this is 0, 5, 535. And when you put it back, because we were doing, I think, f here. So 3 to the power of your, 3 to the power of your answer plus 1 minus 2 times 3 to the power of your answer minus 2, this should give you 5, which it does. So this is going to be your answer. So you can always recheck using your calculator. So actually, I think you are capable of doing all of them on your own. So just use the ideas that we have covered. And you want to simplify, you want to do some algebra, and you want to get to your final answer. So I think it's good practice that if you try to solve B, C, D, and E on your own, because it's using essentially the same ideas that we have done in 1, 2, and in the 2 questions that we looked at for 3. So it says use substitution to solve the equation. And it might not look like it at first, but this is a quadratic equation. If we say that y is equal to 2 to the power x, then my first term is 2 to the power x squared, because these exponents multiplied together to give me 2x plus 32 is going to be 12 times 2 to the power x. So y squared plus 32 is 12y. Y squared minus 12y plus 32 is equal to 0. And this is going to give me y. So that's going to be minus 8 minus 4, I think, if you factor it out. Because minus 8 times minus 4 is positive 32. And then minus 8y minus 4y gives me minus 12y. So y is 8 or y is 4. So 2 to the power x is 8 or 2 to the power x is 4. And x is 3 or x is 2. And you want to take your answer and substitute back in. So it's saying that if I have 2 to the power 2 times 3 plus 32, so if I substitute x is equal to 3, so my left-hand side is 32, my left-hand side is 96, and my right-hand side is 12 times 2 to the power 3 is also 96. So it works. And if I substitute back 2, then I have 2 to the power 4 plus 32, and on the right-hand side I have 12 times 2 to the power 2, which is also 48. So 96, 96, or 48, 48. So both 3 and 2 are correct answers. And now that we have done 4, 5 is the same thing, except for 2 to the power x, you're going to see 5. 5 to the power x is going to be y. And you're going to get y squared minus 5y plus 6 equal to 0. And you can solve this. So I think it's good practice if you solve it, because all of these look like the same question. These are exactly the same type of questions that you see here. So let me just do one to help you. So D, I'm going to say 4x, because I have 4x squared. X times 2 is going to be 4. 2x plus 27 is going to be 12 times 4x, right? So if I say that 4 to the power x is equal to y, then y squared plus 27 is going to be 12y. And y squared minus 12y plus 27 is going to be 0. And let me try to factor things out. Minus 9 minus 3, right? So you can solve it using the quadratic equation. You can try to use the sum and product method to factor it out. But I'm skipping some steps because these are things that I believe you should practice on your own, and once you get used to it, you can easily see. So I get y is 9 or y is 3. And once you get this, you can say that this was 4 to the x. 4 to the x is 9 or 4 to the x is 3. And you get x is log 9 over log 4, or x is equal to log 3 over log 4. And these are just using the ideas that we have done before, because solving this is the same as solving your first question that we did. So to 3 significant figures, so you can calculate it out. Log 9 over log 4. So this is 1.584 something something, and this is log 3 over log 4 is 0.79248 something something. And you can always substitute it back. So 4 to the power 2 times your answer plus 27. So if you substitute this value, you get 36 on both sides. And if you substitute this value, you get 108 on both sides. So 12 times 4 to the power 12 times 4 to the power 1.584, that gives me 108 on both sides. So you can solve it and then always go back to check. And again, question 6 is the same thing. Use the substitution this to solve the equation. So you have u squared minus, and the only difference here is that if I say 2x is equal to u, then my first part is 2x squared minus 5, 2 times x. So this is the only place where I have to simplify, plus 24. So everywhere I see 2 to the power x, I'm going to substitute as u. U squared minus 5 times 2 is 10, and this is u plus 24. And this is something you can solve. This is what we have been doing in the previous question. So question 4, 5, 6, and 7 are essentially the same thing. There are just a few extra steps here. So here you just want to write it as 3 to the power x times 3. So instead of, you get u squared minus 3u if you say that 3 to the power x is equal to u. So that is the only difference. And again, here you have u squared if you say 5 to the power x is equal to u, and you just want to split this into 5 times 5x. So I'm going to leave these questions to you because I think they're going to be good practice. And once you have gotten the idea, if you have understood the ideas here, I think you are more than capable of solving these questions. And question 8 is, again, it's the same question. It's just phrased a bit differently, but it's the same question. Why? Because if I look at 4, 4 is 2 squared. So this is 2 to the power 2x plus 2x, right? And we've looked at this before. So 4 is 2 squared to the power x. And then I can switch x and I can say that, hey, that's 2x squared, right? Because I can multiply them together and I can say, hey, I can flip it. I can say that this is the same thing as saying that 2 to the power x times 2. And now I can say that 2 to the power x is u. And I get that u squared plus u minus 12. So that's pretty much the extra step. And it's going to work for everything here. Because if you look at this, then I just have, well, 9 is 3 squared to the power x. And then here I have 3x times 3 plus 27 times, and this is when you simplify, because I can multiply 2 and x, and I get 2x, and then if I multiply here, I also get 2x. So it's the same thing. The power law tells me that 3 squared to the power x is the same thing as 3x to the power 2. plus 27. So if I say that 3x is equal to u, then I get 2u squared equal to 3u plus 27. And now this is a quadratic equation, and you are more than capable of solving this quadratic equation. So I'm not going to go too much in depth in that. So it says find the value of x over y. And it may look a bit daunting, but it's the same thing that we have been doing for all of the questions. So let me just show you for C. Well, if I take log base 10 on both sides, then I get this expression. Then I can bring 2x to the front, and I can bring 5y to the front. And I can say, hey, well, my x, so if I just want to isolate 2x, and I can divide 5y from both sides. And these cancel out. So I get 5y here, or I can bring 5y to this side. And on the other side, I have log base 10 3 divided by log base 10 4. And now I can multiply by 5 on both sides. These things cancel out. So I get 2x by y is equal to 5 log base 10 3 over log base 10 4. And I can divide by 2 on both sides. So I get this expression. So these are the same question, that same thing we've been doing, but now it just involves one extra variable. It involves two variables when we had been working with one, but it's essentially the same thing. So it says solve this equation giving your answers in exact form. Well, again, just take the log. If I take the log base 10 x to the power 2.5, then I get log base 10 20 x to the power 1.25. I can simplify this as 2.5 log base 10x is equal to log base 10 20 plus log base 10 1.25 log base 10x. And this is just me simplifying things very quickly because I'm sure now that you have gotten used to it and you're probably annoyed from hearing my voice and explaining these same rules. So now, well, I want to solve for x. So let me just take my x terms on the same side. Log base 10 20. And now 2.5 minus 1.25, that is going to give me log base 10x. And that is going to be equal to log base 10 20. So 2.5 minus 1.25, 1.25. So log base 10 of x is going to be equal to log base 10 20 divided by 1.25. And finally, x is going to be equal to, if I raise both sides to 10, then it's going to be 10 times 1 over 1.25, because this is in the denominator, log base 10 20. And there is a reason why I'm writing it like this, because this can be simplified further. So I can actually write it as log base 10 20 to the power 1 over 1.25, right? And this simplifies to 20 1 over 1.25. And you can actually write 1.25 as a fraction, that is 5 by 4. So it's 24 by 5. Because it's in the denominator, so 5 by 4, the 4 comes to the numerator. So you're going to get 24 by 5. So that is the exact value. And yes, I think that is it. So did I miss something? X has to be a positive value. Yes, x has to be positive value. And is there an extra value of x that we somehow may have missed? I don't think so. So I think 20 to the power 4 over 5 should be our final answer. And we can check 20 to the power 4 over 5 should, so we can check. We can always substitute back using your calculator here. So I can say Well, 20 to the power 4 over 5. 4 over 5 is 0.8. To the power 2.5 should equal to 20 times 20, 0.8 times 1.25. And if you simplify it, if you like put it in your calculator, if you do some algebra, then this side simplifies to 400, and the other side also simplifies to 400. So you know that 20 to the power 4 over 5 or 0.8 is your correct answer. So given this equation, we want to find the value of 6x and x. So these are using the same ideas that we've been talking over and over again. So I can write 2 to the power 4x plus 1 times 3 to the power 2 minus x. And I can write this thing as, well, 8 is just 2 cubed, right? So I can write it as 2 to the power 3x times 3 to the power 5 minus 2x. And I can, group things together. I can say 4x plus 1 divided by 2 to the power 3x is equal to 2 to the power 3 is equal to 3 to the power 5 minus 2x divided by 3 to the power 2 minus x. And this is something that we have learned to simplify. 4x plus 1 minus 3x. That is going to be x plus 1. And here we have 5 minus 2x minus 2 minus x. So that is going to be 3 plus 3 minus x, I think. And I leave the simplification for you to check on why that is the case. Because we're going to have this minus whatever we had in the denominator. So 5 minus 2x, 2 minus x, right? And 5 minus 2 is going to give me 3, minus 2x, minus x. So minus 2x plus x is going to give me minus 1x. So now I can take the log. So x plus 1, log base 10 of 2 is 3 minus x, log base 10 of 3. And, well, I can isolate the value of x. So x log base 10 of 2 plus log base 10 of 2 is equal to 3 log base 10 of 3 minus x log base 10 of 3. And I can club my variables, and I'm going to skip some steps here because I think now that you have understood the logic, this should be easy to follow. Plus log base 10, 3. This is like, because we've done this so many times now, is 3 log base 10, 3 minus log base 10, 2. And this gives me that x is going to be 3 log base 10, 3 minus log base 10, 2 over log base 10, 2 plus log 10, 3. And if you just put it in your calculator, 3 log 3 minus log 2 divided by log 2 plus log 3, that is 1.45, right? 1.4526. 1.45 is to 3 significant figures, and you can check your answer. So we have found the value of x, 1.45. And we can leave it at 3 significant figures because it doesn't specify that they need the exact value. So you can check your answer. So let me just put it in my calculator for you and tell you that when you substitute back, what is the expected value? So if you substitute it on the right-hand side, you get 204, if you substitute your value of x, 204,787 something. And this should be the same thing that you get when you substitute your answer on the left-hand side. Times 3, 5, minus 2, eight to the power 1.45 times 3 to the power 5 minus 2 times 1.45. And it gives you exactly the same thing when you substitute x on both sides. So if you know x, you can easily figure out 6 to the power x, right? So you can just solve for x first and go back to 6 to the power x. If you want to directly solve for 6 to the power x first, there might have been an manipulation step that I oversaw. But it's fine. Once you get x, 6 to the power x is just 6 to the power 1.45. Sorry, so you just want to raise 6 to 1.452588. And then you get 13.5. So you want to use your exact value. And if you substitute it back, you get 13.5. So if you're using like fx82, you want to like write your answer to more decimal places. So 1.4525888771. And then when you substitute it to the power 1.4525288771, then you should be getting the same the exact answer as 13.5. Let's see. Is there a step I might have missed that could have helped us to solve? Well, I think yes, there is one way that's popping up to me, and that is that if at this step, right, if I multiply both sides by 2 to the power 3 minus x, and this may look like unreasonable at first, but I hope you can see the logic I'm going for. So I will get 6 to the power of x on this side. Yes. So if I do this, then I can add the powers here, right? So 3 minus x plus 1, that is 4, is going to give me, and if you simplify, this is going to be 3 minus x. So 2, 4. So, and again, if I simplify this is just 6 cubed over 6x. So 2 to the power 4, that is 16. So 6 to the power x is 6 cubed over 16. So if you solve 6 cubed over 16, then you get 13.5 directly. So there is one you could have done this manipulation in between to get 13.5 directly. But the first method also works. And now this looks very, very similar. So yeah, so it's just recognizing patterns. I have 2 to the power something. I can write this as 2 to the power 2x. And I can write this as 2 to the power 3, x minus 1. And I can write this as 2 to the power 3. And that makes it much easier to solve. So I have 2 to the power 3. Inside my bracket, I have 3x minus 3 minus 1. When I multiply this out here, 7, 2 to the power 2x minus 2 to the power x plus 1. And now, let me just multiply things in. So if I multiply, then I get 2 to the power 3x minus 2 to the power 3 on my left-hand side. If I simplify things, because if I multiply this, I'm going to be forced to add the powers, and 3 plus 3x minus 3 is just going to give me 3x. And on the left-hand side, I have 2 to the power 2x minus 7 times 2 to the power x plus 1. And I don't really like keeping it as x plus 1, so I'm going to write it as 2 to the power x times 2, and 7 times 2 is going to give me 14. And I think now that we have arrived at this point, I can write this as x squared. This is going to be x cubed. So let's say that 2 to the power x is u. So we're actually solving u cubed minus 2 cubed is 8, 7u squared minus 14u. So this is actually a degree 3 equation. This is a trinomial equation. So u cubed minus 7u squared plus 14u plus 8 is going to give me minus 8 is going to give me 0. So this is just bringing all my variables to one side. So now I want to look for solutions of these equations, and there is no easy way to figure it out. So my method is sub in numbers. So why am I subbing in numbers? So if I sub in a number like 1, so let me just sub in 1. So I get 1 minus 7 plus 14 minus 8, right? And 1 minus 7 plus 14 minus 8 gives me 0. So that was a brilliant sub, because it gives me exactly what I need. So if I sub in 1, then this expression is 0. So I know that u minus 1. So if I subbed in minus 1, then this was going to be u plus 1. But I know u minus 1 is a factor of this thing. And this is borrowing concepts from the remainder and factor theorem, which I don't think you have learned yet. But basically, idea is you sub in a number, and if that number, when you sub it on your variable side of the equation, if it plops out 0, then then your variable minus the number that you just substituted is going to be a factor. And now that we have factored this out, u minus 1, we can also get the other factor. So we're going to divide u cubed minus 7u squared plus 14u minus 8 by u minus 1. So u times u squared is going to give me u cubed. And u squared times minus 1 is going to be minus u squared. And I can subtract. So u cubed minus u cubed is going to give me 0, minus 7u squared plus u squared minus 6u squared. And I'm going to bring everything else down. I'm going to have to multiply by minus 6u. If I multiply by minus 6u with u, I get minus 6u squared. And I also get plus 6u when I multiply by minus 1. So if I subtract, this is going to collapse to 0, and I'm going to have minus 2u minus 8. And I can multiply by minus 2, minus 2u plus 2, but I have a remainder minus 10. So I don't think that I can easily write the second term as a quadratic factor, because I get u squared minus 6u minus 2 minus 10 over u minus 1 equal to 0. And, well, we can't really say that this has the roots that we want. So I think u minus 1 should be a root that is the only thing that is solving the equation, if I'm not wrong. So 2 to the power x should be equal to 1. So x is 0. That looks like the only solution, because this does not look like we can solve this. But let me quickly just check it for you. If you plot the graph, you can use Desmos to check it out. I'm going to use... So it looks like it only cuts one. There's only one real root. But we can check. So let me use Desmos to check. So our graph was u cubed minus 7u squared. U cubed minus 7u squared plus 14u minus 8. So it does have roots. So I think we might have made a mistake while doing the division. So it has roots at 1, 2, and 4. So we figured out 1. So So I think we made a mistake while division. So let's just go back to our division board. I'm so sorry about that. So we're gonna redivide and like figure out our solution. So we were saying that u minus 1 is gonna be a factor. So you get u squared here. If I simplify this, it's the same idea. I'm gonna get minus u squared here, plus 14u. So minus 6. So I get plus minus 6u. So this gives me plus 6u. And when I subtract 14, that is giving me 8u minus 8. So that's going to be plus 8. So it's actually u minus 1, u squared minus 6u plus 8. So I made an arithmetic mistake while doing long division, but I think you get the idea of long division. It's very similar to regular division. So you're just looking at what number do I multiply my variable to get the first term, and I multiply by u squared. And when I multiply them, I get u cubed. When I subtract them, and I have to multiply it with my other term as well. So then I get minus u squared, and I subtract. So minus of minus is going to be plus. So minus 7u squared plus u squared is minus 6u squared. This is 0. And then you go on. So if I multiply by minus 6u, I get minus 6u squared. And then when I multiply, I get plus 6u. And then I subtract. So this goes to 0. And 14u minus 6u gives me 8u. And then I just bring my minus 8 down. And lastly, if I multiply by 8, I get 8u minus 8. So u squared minus 6u plus 8. That is 0. And I have u minus 1, u. So you can factor this out. And I think you get... your factors are minus 4 minus 2 equal to 0. So your solutions are u1, u2, u4, which is the same thing that we saw on the graph. u1, u2, u4. And finally, we can say that, hey, 2 to the x was our u. So x can be 1, x can be 2, and x can be 0, I think. Because when we solve it for 1, 2, and 4, well, 2 to the power 0 gives me 1, 2 to the power 1 gives me 2, and 2 to the power 2 gives me 4. So we have 3 solutions, 0, 1, and 2. 1, 2. And where's the pencil button? So this should be your answer. And we can always check. So if I go back now, if I erase everything and if I go back, then I can say, well, hey, if I substitute 0, then I have 8, 8 to the power minus 1, 7, 4 to the power 0 minus 2 to the power 1. So this is going to be 1 minus 8 equal to 7, 1 minus 2. So minus 7 is equal to minus 7. So yep, it works with 0. It should work with 1. So if you substitute 8, you get 1 minus 1. This is 0. And if I substitute 1 here, this becomes 4. 4 minus 4 is 0. So yeah, it works. And it should work with 2 as well. So that is the answer. And we are done with the topic of solving exponential equations.